All right, good morning. Well, it's morning for me. Good morning, students. I was asked to go over pages 149, 133, and 134, so I'm going to try to keep this video as quick as I can. Please know that you'll be able to pause, rewind, or fast forward if you need to move on through something. The first page is page 149. This is the one on the rock cycle, understanding the main ideas. So you had a diagram to label and several questions to answer. This first page that's located right in front of it is actually where you're going to find these answers. In my Adobe, I was able to go through and highlight passages that answered my questions. But we'll start here with the rock cycle diagram. It asks you to use the terms to fill in the blanks. So you have metamorphic rock, sedimentary rock, magma, and igneous rock, and also the word pressure. So as you look through the events that are occurring in the rock cycle, here you have erosion, you have heat and blank, melting, and a volcanic activity. Over here is where I typed the answer, so it'll be easier for me to show you what you needed to copy down. So for number one, I put igneous rock because igneous rock is the type that's going to be formed from a volcanic activity. You can have two types of igneous rock, intrusive and extrusive, and it's going to depend on its location. All right, next is erosion. So erosion is the event that is occurring. In order for you to have a rock created from erosion or weathering, you're going to have sedimentary rock because it's going to be the small pieces of various rocks binded together. After step two, you have heat and blank. So pressure, heat and pressure is one of the other ways that another type of rock can be formed. So for number three, I put pressure. That rock that is formed from heat and pressure is going to be metamorphic. Remember that metamorphic rocks are the ones that have those bands or ribbon-like stripes throughout it. All right, the metamorphic rock can begin to melt, and then that melted rock is going to form into magma, which is number 5. All right, I do apologize if I'm going too quickly. Because I use free programs, I have time limits, so I try to get to what you need as quickly as possible. All right, so for number 6, how do constructive and destructive forces contribute to the rock cycle? Well, if you go back to the previous page, let's see if I can move it over. All right, so I highlighted Earth's constructive and destructive forces move rocks through the rock cycle. But that would be the answer that you would have put, which is what I underlined: Earth's constructive and destructive forces move rocks through the rock cycle. But what exactly are those? So I also provided you with a description of each. Constructive forces are the ones that build. So if there's new crust, it would be in the form of a mountain, an island, deltas, or sand dunes. All of those are going to come from constructive forces, which is a mechanism of where Earth's crust is being pushed upward. Destructive forces are going to be those that break down, but new landforms can be created from a destructive force. Most of those would be caused by weathering and erosion. All right, so number 6, describe an alternative pathway within the rock cycle. All right, so from looking at this diagram, it shows you that all of the rocks can go through various interchangeable pathways within that rock cycle. The example that I use for you is that the rock cycle is a continuous process of rocks being formed and changed from one type to another. The example that was provided in the reading passage is Stone Mountain. Originally, Stone Mountain was a type of granite rock that was pushed upward. So the granite formed underneath the earth, and as it pushed upward out of the earth's crust, the weathering and erosion that it went through caused it to become quartz, which is the bulk of its formation now. All right, so for number 8, describe how the granite of a mountain could change first into sandstone and then into quartzite. All right, so let's go back to your passage. So here, over millions of years, layers of sand will build up. The process of compactation and cementation will eventually form the quartz particles into sandstone, which is a sedimentary rock. As more and more sediment piles up on the sandstone, pressure on the rock will increase, the rock will become hot, and after millions of years, heat and pressure will change that sandstone into a metamorphic rock, such as quartzite. So for number 8, I just basically took portions of that as far as it piling up on the sandstone. Pressure will increase, and then it will be a metamorphic rock, quartzite. All right. For number 9, what do plate movements cause? What do plate movements cause that drive the rock cycle? So going back to your passage, here in the bold, and I'm sorry, my highlights are all over the place. Plate movements drive the rock cycle by pushing rocks back into the mantle, where they melt and become magma again. The movements can also cause folding, faulting, and the uplift of crust that moves rock through the rock cycle. So any portion of that, bold print would provide the answer to number 9. Plate movements drive the rock cycle by pushing rocks back into the mantle where they melt and become magma again. All right, and then for number 10, I didn't put a specific statement because it says in your own words, write a definition of the rock cycle on the lines below. So whatever you feel the rock cycle is, as long as you have something that states that each one of the rocks is constantly being changed from one type of rock to the other, anything along those lines would be an accurate answer. All right, so let's move on to the next page. Page 133. Again, for page 133 and 134, the passage that comes first is where you would find your answers. So this passage on page 132 is the one that you should have read in order to answer your questions about igneous rocks. All right, so question number 1. Fill in the blanks in the table below. So after you've read, it's asking you about some types of igneous rock. So in this passage, it gives you that the igneous rock comes from, or has the meaning fire. So it comes from a volcanic eruption. It tells you how they're classified. It gives you extrusive, intrusive, porphyric texture, and I think that's it. So usually what we do in class, whenever I give you a passage, I ask you to read it. I ask you to annotate that passage by highlighting, underlining keywords, terms, anything that you can use as a source for your answer or to give you a better understanding. All right, so let's go back to our worksheet. Slow cooling of magma far beneath the earth. So for number 1, you should have put an intrusive rock because that is the type of igneous rock that forms underneath the earth. Intrusive, in meaning inside. Magma cooling in 2 stages, first slowly, then quickly, is going to be a polyphyric rock. This type of rock meets that description. The type of igneous rock that forms from extremely rapid cooling of lava, which there are no crystals. One example would be granite. And then for number 4, rapidly cooling lava in which tiny crystals form. For number 4, it's going to be basalt. All right, so 5 through 7 were short answer questions that you needed to answer. Again, the information is going to come from the passage. Number 5, explain how silica content of molten material affect the color of igneous rocks. Well, if you go back to your passage, let's see how quickly I can find it. Slow cooling magma forms coarse grained rocks with large crystals. Intrusive rocks have larger crystals than extrusive rocks. Some intrusive rocks have large crystals scattered on the background of much smaller crystals, creating a porphyric texture. So for number 5, low silica content usually forms dark colored rocks such as basalt, and then high silica content usually forms light colored rocks such as granite. Now that statement wasn't word for word from what was given in the passage, but based on what I read, that's what I came up with. All right, for number 6. What qualities of igneous rocks have long made them useful for tools and building materials? So I put that the uses of igneous rocks are tools and building materials. Granite is one of the most abundant igneous rocks, and it has been used for statues, building bridges, and public buildings. All right. If you go back here, okay, here in the last paragraph, many igneous rocks are hard, dense, and durable. As a result, people have long used igneous rocks for tools and building materials. Number 7. All right, so for number 6, the qualities that make them long and useful. And I was rushing to get this type. Oh, here it is, number 6. The qualities of igneous rocks that have made them useful tools is that they are hard, dense, and durable. Describe one use of the igneous rocks for granite, basalt, and pumice. It didn't provide you with a lot of detail about that. Here, igneous rocks such as basalt, pumice, and obsidian also have important uses, but the granite was the one that they gave you the primary description of, but all of them can be used for statues, building bridges, and public buildings. All right. Number 8 through 10 is fill in the blank. Again, the information is going to come from the passage. Igneous rocks that form from lava on the Earth's surface. Remember, if they're on the Earth's surface, they have exited the crust. So that's going to be an extrusive igneous rock. 9. The rock with large crystals scattered on the background of much smaller crystal has a blank texture. The texture that was described in your passage was polyphiritic texture. And then 10, igneous rocks that form magma below Earth's surface, which is going to be on the inside, is going to be intrusive. Alrighty. Last sheet. This is page 133. For most of the, every answer that you needed for this particular one was either going to come from the passage or this chart that is provided for you. So it's asking you to look at this chart and then answer the questions below. Notice that the intrusive rocks have coarse grain, and the 3 types are here. Intrusive rocks have fine grains, and those 3 types are here. Based on each one of the columns, you'll see that those 2 minerals have the same mineral composition, and the coloring is going to be the same. The main difference between the 2 is that they're either intrusive or extrusive. All right, so let me pull this sheet up so you're able to see those answers as well. All right, so for page 134, which of the 6 kinds of rocks are intrusive? Which of the 6 kinds are extrusive? So if you look here at the chart, intrusive rocks are the ones going straight across on that row. You have granite, diorite, and gabbro. Extrusive rocks are the ones going straight across in this row. You have rhyolite, andesite, and basalt. So for your answer, you should have written intrusive rocks are these 3. The extrusive rocks are these 3. Question 2, compare granite with rhyolite. How are they similar? How are they different? So granite and rhyolite are both made up of quartz, feldspar, and muscovite, and amphibole. So here are the minerals that make up the granite and the rhyolite rocks. Next part of it says, how are they similar? And for the similarities, I put that both of them are made up of the same minerals, and both are light colored, because if you look at the bottom of their column, the color for these 2 is going to be light. Then it asks you, how are they different? Granite is an intrusive rock and has coarse grains, whereas rhyolite is an extrusive rock and has fine grains. And I was able to get that information based on the column to their left because it told you where each one was classified. Number 3, compare the mineral composition of diorite with the mineral composition of andesite. So again, these 2 are in the same column. Both will have the same mineral composition. Both will have colors that range from a medium gray to green. because they are in that